Pretty sure we talked about parallel arrays, did we not?
Yeah.
So we're going to do a little bit more about arrays. We're going to talk about two-dimensional arrays. Then we're going to talk about vectors. Vectors is kind of the C++ equivalent to some of the cool classes like the array list class in Java, so that you can create. Well, the problem with arrays in pretty much all languages that call them arrays is that they are limited in length, meaning that once you declare one to be 20 elements long, it's got to be 20 elements long forever, unless you feel like allocating a new array that's larger and then copying all the elements into it. Whereas that's kind of lame. There are data structures, array lists, vectors, other things like that, that will grow as you need them. We'll be talking about those. So the idea behind a parallel array is that you have two or more arrays of the same length. And they're linked by their index number. So here we have employee 1, 2, 3, 4, and 5, and we have their gross pay. Ew, man, that's gross. So linking them by their index number, employee 1 has a certain number of hours and a certain number of pay rate per hour. So this isn't actually the array, but this is. And so the first employee, index 0, 10 hours a week at $9.75, earns $97.50. Second employee, index 1, 862 at $15 an hour. And so on. Once you start using classes, the need for parallel arrays kind of goes away. Arrays as function arguments. Kind of talked about this. We still need to talk about pointers, and we need to talk about references, so I'm going to hit the topic really quick. And then we're going to go back to it in its proper chapter. Alright guys, I know I'm incredibly boring, but out of the like 6 people in here, only one of y'all are actually gratifying my ego and watching me. So.
I already have my project created. I'm just waiting for you. I've just been waiting for you to get everything cranked up and ready.
Cool. Alright, so I'm going to make a new project, new boilerplate. The idea behind a pointer is that it is not the variable itself. It contains the memory address that the variable sits at. And this is a concept that is totally not allowed in Java or in Python. You just flat out don't have pointers in those languages. So the idea behind a pointer is I'm going to make a function here called changeIt that takes an x, changes the value of x. X is equal to x plus 1. So down here I'm going to create a variable, I, for integer. I'm going to set it equal to 10. Then I'm going to call changeIt, passing in I. And then I'm going to see out the value of I. So what is I going to equal to by the time this is done?
11?
That would be cool. However, this is a copy of the data that gets passed in. This is a local variable that gets a copy of 10. So it can do anything it wants to that variable. I is still equal to 10. That's what's known as pass by copy or pass by value. C, C++, is passed by copy. So is Java, Python, everything else. Well, let's run it and prove it. When we're done, when we print I out, it's still going to equal 10, even though this looks like it would have increased. I mean, we could even print this temporary variable out here, you know. But we're going to see that although this is 11, that I is still equal to 10. There we go. We ran it. It bumped up the local variable x. A parameter is a local variable. But that didn't change the original variable. What if you wanted it to change it? Well, back in 1970, when they invented the C language, they invented the concept of pointers. And then later, in the 90s or whatever, they came up with the idea of references. So we're going to do pointers first. What is a pointer? You declare a pointer like this. Int star. Star means this is a pointer. And then you set it equal to the address of I. Give me the address of I. All right, now well, let's see out what PI contains. But let's also see out what it's pointing to. So I ran it. Check out what PI equals. It equals that huge long hexadecimal address. It is a pointer. It is a pointer to a specific byte in memory that contains the I variable, contains the address of the I variable.
So it's going to be different for each computer, though.
Right, right. So when you run it, you're not going to see that at all. You should see 10. So if you want, we can change that value. Star PI is equal to 11. And then if we print that stuff out again, I'm just going to copy and paste. It'll show that the address is the same, but the value has changed. And there we go. So after that line of code, the bytes in your computer at that address now contain an 11 rather than a 10. And really, no other high-level language lets you get at the data in this fashion. Why is that? Because it's so easy to mess up. You know, you could change the value of PI to anything, and then you could start writing, data to it. You do something like this. PI is equal to, I don't know, 8,000. But that didn't work. I'm not going to mess with it, but you get the idea. If you started changing PI itself instead of the memory that it pointed to, then you'd be writing to places in memory that your program is probably not supposed to write. Arrays are treated like pointers. So I'm going to declare an array of ints. I'm just going to call it nums. It's going to be 4 elements long. And I'm going to fill it with the values 10, 20, 30, 40, just so that we have something to look at. So if we see out I don't know if this is going to work. I may be forgetting this. If this doesn't work, I'm going to back out of it and delete those 2 lines and not even explain what I was trying to do. Okay, good enough. It didn't print out what I wanted, but I'm going to get rid of that +1. Notice what I'm not doing. I didn't put an index number here. All I did is print out that variable itself. So, look at that, it's another address. So an array is just a pointer to a place in memory in this language. So I could use the same syntax to get a hold of that data. Int star PA, that's a pointer to my array. And then I could print out PA followed by the memory, the data that is contained at that pointer. Like that. And it should print out a 10.
What's the ampersand for then? You didn't use it down there, but you used it up there.
Let me make sure this worked before I go back to that. Okay, and there's a 10 stored there. What the ampersand means is the address. We have a variable here, which is an integer, and so I wanted to store the address of it into the pointer. Now nums already is a pointer of its own. It's already an address, so I didn't need to take the address of it. Yeah, that's the difference between that syntax and that syntax. So when you have a pointer, you can increment it and see what's in memory at those specific points. What do I mean by that? Let's write a little loop. For int, I've already used I, so I'm going to use x. X is 0, x is less than 4, x plus plus. Now take this line of code right here and paste it. Didn't do a darn thing because I forgot to change it. PA plus X. And then over here, change that to parentheses. So I had to do that. I put that into parentheses to make it blatantly obvious what I just changed. And then I had to do that. What this is saying is, I want you to go one, past what your pointer was, and then print out the value at that address in memory. Now I'm not totally convinced this is going to work. We're going to find out. Yeah, there we go, 10, 20, 30, 40. Now there's some black magic going on behind the scenes, because when I said pointer plus 1 is 1 past 8 equal to 9, no. Is 1 plus C 0? No. Every time I add 1 to the pointer, it's actually increasing it by 4. Why would that be?
Because you set your number of, or is it maybe the length of your array?
Yeah.
That's a coincidence. But that's a terribly good guess. It's because an int is a 4-byte data size. So somehow, C++ knows that when I add a value to a pointer, I'm actually adding enough to go to the next value in the array. And I honestly don't know how it does that. There we go, 10, 20, 30, 40. Like that. So this is an alternate syntax for dealing with arrays. It's one we're not going to use now that I've demonstrated it. But I wanted you to get the idea of an array. It's just a number that contains a hexadecimal, well, not a hexadecimal address, that's just how it gets printed out. It contains an address, which is one of the bytes in your RAM, and you can access those bytes directly. The way you do it is with the asterisk syntax. So what I did here is when I declared a variable called I, and then I wanted a pointer to I, my convention, and it's one that a lot of people follow, is that you stick P in front of it in order to indicate that it's a pointer to I. So if you're going to create another one, like temperature, and it's a double, set it equal to 98.6, and then you wanted a pointer to that, double star P temp. This is a pointer to our temperature, and it's equal to the address of the temperature variable. And now we can print it out. Now to print out 98.6. And that looks like we're going around our elbow to get to our nose or something like that, you know, in order to go to that much effort just to print out 98.6.
What's the point of that?
The point of it, though, is that that's a way to pass data in so that this could actually change it up here. This function up here could actually change bytes in memory so that if we pass something in, it has an effect on data that is declared down here. That's its primary purpose.
So that's, so to not get the pass in value or pass by value, you just use a pointer. So
Right.
you're actually directly pointing to where it's at. Okay,
Exactly.
Okay, gotcha.
Right. So when you're accessing not the pointer, but the memory that it's located to, if you follow this nomenclature of putting a P in front of it, then for every P you have, you'll probably have a star. Because you can have a pointer to a pointer if need be. This is going to look stupid, but double star star P temp is equal to the address of the temp pointer. Now I'm going to print that out. I'm going to print out PP, oops, I forgot to call it PP. There we go. So print out PP temp followed by star PP temp, and I need to put spaces between all these, followed by star star PP temp. And this is like the least important thing, so we're not going to spend a lot of time if it didn't make immediate sense. All right, so that's the pointer to temp, and this is the pointer to the pointer, right. And so if I want to access ptemp, when I print it out, I print star ptemp. When I want to print out the memory that the pointer to the pointer prints out, I use star star, you know. It's called dereferencing it.
So if you use a pointer that's pointing to a pointer, and that pointer is pointing to an area in memory, but like how it's pointing to where double temp is, if you modify the pointer that's pointing to the pointer, is it still going to modify the actual data to where that pointer is pointing to?
Yeah, then now it's pointing
Okay.
somewhere else. Just
Okay.
like this guy, when we were adding one to our pointer,
Mhm.
and so it was pointing to a different address in memory. You know, you can make it so that very quickly you were not pointing at what you thought you were pointing by changing these pointers, or these pointers to these pointers. So the reason that we care about all this stuff, we're going to scroll back up and we're going to modify, change it to P change it for pointer. Void P change it. And instead of taking an integer, it takes a pointer to an integer. So I'm going to call it px because it's a pointer. And then so star px plus plus, because that's a shortcut for saying x is equal to x plus 1. And then C out x equals star px NDL. So we dereference the pointer to print the contents of the memory by using the asterisk. Now down here, instead of calling change it, I'm going to call p change it. But that means I have to pass in the address. So I'm going to put the I there. Excuse me, an ampersand there. That didn't fix it. What are you complaining about? P change it is undefined. Oh.
Put P change in.
P
Sorry,
change
I was gonna
int.
tell you.
All right, there we go. Yeah. There we go. X and I are going to be changed when I run it. I hope. Wow, X is completely weird.
I got negative 8 billion or 85.
Maybe I should have done this. I'm going to make a change. There it goes.
What'd you do?
I put the parentheses around that.
Can I see your code in the name?
Yeah. That's what I changed.
So without the parentheses, what was it actually
What was it
changing?
doing?
Yeah.
Is plus plus had higher priority than the pointer. So it was incrementing px by 1,
But not the pointer.
but not the area that it was pointing
Okay,
to.
gotcha.
Right.
Bless you.
Thank you.
Bless you.
Thanks.
Okay, so that's one of the primary uses of pointers. The other is, I haven't done C++ professionally in about 15 years, so I don't know if this has kind of stopped being of use. But people would declare structures. A structure is a class with no methods, it's just data. And then they would store, when you would allocate a new structure, you would call a function called alloc or malloc, and would create enough memory in order to store your structure. And then you could fill that structure full of data. But what you had is a pointer. So you would reference it, by its pointer in order to change it. Nowadays with classes, people tend not to manage data in that fashion anymore. You don't have to malloc with the malloc command. And that's good because you used to have to malloc and then you would have to free your data. What does that mean? Well, when you tell your program that you need 10 kilobytes to store your array, then when you're done with it, you better have released that 10 kilobytes, or else you'll get what's known as a memory leak, which is that the longer the program runs, it keeps allocating memory, but it never frees it, so it uses up more and more and more and more RAM. Firefox used to be a notorious memory leaking application. For years and years and years, the longer you let it run, and if you're one of those people who never reboot your computer, and 5 days later you look at Firefox and it's using, 7 gigabytes of RAM. So you close it and open it. Yeah, they fixed that, but it was like that for a long time. So whenever you alloced memory with the malloc or alloc command, you always had to turn around when you were done with it and free it. Now, when the application exits, it is free, but if you kept the program running, and that memory was never freed, and you had it like in a loop or something, or every time your function was called, it would allocate a little bit more and never release it. So anyways, primary use of pointers that I can think of now. However, C++ introduced something else called a reference.
Just in a, I guess like a real world example, when would you use a structure?
Different topic. A structure is just a class with no methods. So if you're going to have some data that you want to pass around, then you could declare it as a struct. But honestly, after a certain revision of C++, they made structs and classes absolutely identical. So if you want to put methods in a structure, you can. The only difference is that by default, the members of a structure are public, and by default, the members of a class are private. It's the only change between the two.
Is that only C++?
Correct.
Like in Java, you have to declare private or public.
Right, right. And there is no struct keyword in Java, because in C++ they're the same thing except with that default now.
Gotcha.
So you hardly need it. Okay, so we're going to write one more version of pChangeIt called rChangeIt for reference. Void rChangeIt. It's not going to take a pointer. It's going to take a reference. Cout x equals x ENDO. I'm going to put the name of the function in the cout so that, I know which one is which. don't be fooled, but I'm putting the closing braces on the same line as the definition of the function. The reason I'm doing that is so that I can do this. R, change it, and then I just pass in I, like that. I'm going to comment that line out, the P change it call. And originally, we just had a change it call that looked like this. The problem with that one is did not change I. This one did change I by passing in the address of I. This one passes in a reference to I, so it is also going to change it. If you look at it, the syntax for calling it's a lot clearer, right? You're not having to put an ampersand in front of it. And the syntax for accessing the memory, we're not having to use, you know, this funny syntax for dereferencing it. We just increment it. So what this says is, oh, I want that this is actually the same thing as this. They are two references to the same piece of memory. And then the compiler goes in and magically makes that happen.
And that's only because you put the brace on the same line?
It's because I put the ampersand in front of the X.
Oh,
Right.
no, I was curious on what your whole explaining for the brace being on the same line was. Sorry.
Oh, I was just making a.
Oh no, I thought you were doing it for.
I was doing it to save space on the screen so I
Oh,
could get
sorry.
more data on the
Okay.
screen. Yeah. All right. So here's our three functions. This one does not change the value of X at all once you get out of it, because X is just a local variable. Here, X is a pointer to memory, and so if we reference it in this fashion, we can actually change the data that of the parameter that was passed in.
Did you change the main also?
Not since I wrote it.
Okay,
I had change it as the version, which was the first version, and then I had P change it for the pointer, and then I had R change it for the reference. So, adding a comment, X is a reference to the argument being passed in. And here, X is the address of the argument being passed in.
So
And here, X is a copy of the argument being passed in. This does not exist in Java, unfortunately. It'd be really handy if it was. This also does not exist in Java. I'm just commenting for y'all who are currently taking a Java class. The one way you can get around that, though, is that if you're passing in an object rather than a variable, a primitive variable, then you can still start changing values that are contained by the object. That is okay. And we'll see that when we deal with the arrays in a minute. Okay, so that's going to make the chapter on pointers go by more quickly. That's okay.
So is either one better than the other? For P change it and R change it?
I like this one better, myself. Performance-wise, I don't know if there's a difference. I doubt that there's any difference performance-wise. Compilers are good and optimize the code nowadays. They probably do the same thing.
So you
To me,
just-
this looks less risky. The syntax is so much cleaner for accessing the values of it. You know, when I did that wrong,
Oh yeah, we got a different value.
we got a different value because I did not use the exact, you know, I didn't cross my eyes and hold my fingers in the exact right position when I accessed it. So I prefer this one.
I don't know, I just felt like if you're actually getting the actual address of what you're trying to change, I figured that would be more, I don't know, optimal, I guess I could say, because you're going.
You'd think it would be faster, but like I said, the compilers, they put so much effort into coming up with optimizing compilers, I really doubt it's any different. Behind the scenes, it's rewriting this code to make it look just about exactly like that as you compile it. Okay, so in our notes, int x, x is an int star px is equal to ampersand x. Px is a pointer to the x variable. If you want to change its contents, star px is equal to 100. X is now equal to 100. Okay. So back to where we were. To pass an array to a function, just use the array name. Now I kind of showed y'all that what an array is behind the scenes. It's a pointer. To define a function that takes an array parameter, you'd give it a name like that, but you don't specify a size for the array. This showScores function is going to be accepting some argument that is an array, but we don't know its length. We're not specifying its length.
We're not specifying its name either, right?
Well, we got, this is a prototype. When you define a prototype, you don't have to give variable names. That's kind of weird. Remember what a prototype is. A prototype is like if I move these functions down here to the bottom of the code to get them out of the way or to put them in another file, then no longer is the code going to compile anymore. This stuff, it's not going to know what R change it is, or what P change it is, or what change it is. So when I try to compile it, we're going to get errors here. There were build errors. So you have to forward declare your functions with prototypes. R change it took a reference to an int. Is there anything wrong with putting the variable name there? No, not at all. In fact, I prefer it. But you don't have to.
I was just saying, I guess if you didn't know what the variable name was.
Well, when you actually write your function itself, you better give it a name or else you're not going to know. But right. For the prototype. The name of the parameter, though, is actually good data, you know? Because if you see something like this, void do something, and it takes a string, you don't know what it's doing. You don't know what this data is. If it said string name, that at least gives you a clue.
Gotcha.
So I like to declare my prototypes exactly with the same, you know,
Same syntax as.
same syntax.
Yeah.
Right. So a prototype just looks like the declaration of the function, but instead of having a body, it's just got a semicolon at the end of it. So we had three functions. If I was going to prototype all three of them, it looked like this. P change it took a pointer, and then change it didn't take anything special at all. It just took an int. So now we're going to write a function called printArray. But I'm just going to declare the prototype, and then I'm going to scroll down and actually add it. Nah, that's annoying. Let's just actually write it up here. Or better yet, SumArray. Int sum underscore array, which takes an array, but we're also going to pass in the number of values. Int length. That's the length of the array. And I used the wrong syntax. It went ahead and compiled, but we're supposed to be putting the square braces after the variable name. I don't know when that became a thing.
Mine didn't do it.
Used to be that we had to put that next to the data type rather than after the variable name. All right, now let's sum it. So this is your typical summing function, where you have to declare a total, and then you rip through the array with a for loop or something like that, adding up all the values in it. So int total is equal to 0, and then for I is 0, I is less than the length of the array, I plus plus, and then total is equal, plus equals, total plus equals the array at position I, and then return the total. Let's write another one that prints those elements. Going to be almost the exact same thing, except we don't need a total variable. And it doesn't need to return anything, so I'm going to call it void. So this is going to be called print array. Still going to accept an array. It's going to accept a length parameter. And the reason we're having to do that is C++ does not have a reliable way for determining the length of the functions of the arrays. You can hack it by using the size of function, but that is only guaranteed to work if you're actually in the same block of code that where you allocated their array, especially if you're passing it around as a reference, which sounds odd. So anyways, let's write another for loop for int I is equal to 0, I is less than the length, I plus plus. So let's write out that number followed by a tab, followed by the actual value, which is a sub I, followed by ENDL. And that should be enough. Now I'm going to write a test for those two functions. Void test is going to declare an array of ints. I need to take some spaces out. I'm sorry, it makes the code harder to read. Int Jenny, we're going to use Jenny's phone number as our data. 8675309. Now we're going to get the sum of those numbers. Int sum is equal to sum underscore array Jenny. But we don't know the length of the Jenny array, so we need to get the length of the Jenny array, or we just need to count the pieces. 1, 2, 3, 4, 5, 6, 7. It's a phone number, so we could hard code a 7. That's pretty bad programming. What we really should do is declare a constant that's the length of the Jenny array. So const int, let's define it after the array itself and use size of to determine it. Constant int the length of Jenny. I'm using a capital L just because lower case is hard to differentiate between a 1, is equal to the size of the array divided by the size of an int, because it's an int, an array of ints. And so now when I call the sum function, I'm going to pass in both the array and the length of the array. Same for the print function. I'm going to call print array, pass in the array itself and the length of the array. And then I'm going to print out the sum. Sum of Jenny is Jenny followed by followed by the word sum, followed by ENDL. I'm going to take some spaces out by moving the braces up to the previous line. That didn't buy me enough space. The last thing I want to do is the first line of main is now going to be a call to the test function. Like that.
So you have to do it and go run that. Oh, wow.
Yeah, I just wrote a test function and I stuck a call to it up at the top of main. Does that make sense? So the sum of Jenny's phone number is 38. I guess that's all we needed to know about it. And then there's the 7 digits of the phone number. I'll stop here, do a walkabout. All right, so to pass an array to a function, you just use the array name. You want to show the scores? If tests is the name of your array, then you just pass it in like that. To define a function that takes an array parameter, you define it using the empty square braces, like that. Int, tests, and then square braces. I wish I hadn't shown that because that makes it. Anyways, yeah, sure, that's how you define a prototype, but I care more about how you declare the function header. So when passing an array to a function, it's very common to pass the array size so that the function knows how many elements to process. So show scores takes tests and a variable called array size. So you just declare that as you would expect, as we did. You give an array name like this, but then you also allow the programmer to pass in a second int, which is the length of the array.
So when you print out the size of the int, does it give you the actual number, or is it giving you like a place? I don't know. It's a big number and it has a D in it, so I'm just like, I don't know.
Well, if you did size of an int, it ought to print out 4.
It printed out 4. Oh, yeah, it did print out 4, but I didn't put it in line. So what it did is it did the p change.
So you saw something else
Yeah.
after it, yeah. So when you do that thing, when you do constant int size is equal to size of the array divided by the size of the array type, quite often what you'll see people do is they'll say the size of the array divided by the size of the first element of the array. That's slightly risky because if the element is of 0, if the array is 0 elements long, then that would actually give you a divide by 0 error. So if I know the type, I'd rather put the type there rather than do that.
I guess I just don't get how that works.
Well, if you declare A as a array that's 10 bytes long, like this, and then you call size of on it, it's going to print 40. Why? Because A is 10 ints, each int is 4 bytes,
Okay.
so 10 times 40, or 10 times 4 is 40. So the size of the array is 40, the size of an int is 4, and so the
Okay.
size of the array is 10.
I guess I'm seeing. Okay, I get it with that, but like the size of a double and stuff like that, that would give you some wonky numbers, right? Or would it still give you like?
Well, if
the
you
same
used doubles instead of that, you better change this as well. But since a double is 8 bytes, then the size of that array is 80 divided by the size of the double. A double is 8, so it still will come out as 10.
Never mind then. I see what you're saying. I didn't know how big like all the other data types were.
Yeah. So you saw that when I changed the data type here, I also had to change size of here as well. That's why it's not a bad idea to actually use the first element of the array to get its size. But like I said, if the array hasn't been allocated yet, well, that's not it. If the array has been allocated to size 0, which is actually a possibility, you could do that. That is legal. Why would you do it? I don't know, but you can. Then if that was 0, and then we try to access the first element, if it's 0 long, then that's an error. So I'm going to change that back to double, even though I'm probably not ever going to show this specific page again. All right. Guess I could copy and paste this into our notes. This is very similar to our print array function. It takes an array of nums, bless you. It takes the size of the array, and then it uses a for loop to print them out. So an array name in a function is like a reference variable. No, it's more like a pointer. Changes made to the array are reflected in the actual array. So you need to exercise caution to make sure that your array is not inadvertently changed by the function. What does that mean? Well, if we went back into our code, and if for some perverse reason we decided that as we were going to print it out, or as we were summing it, we were changing the values to 0. Let's do it here. A sub I is equal to 0. Don't make this change because this is stupid. That erases the data that's in the array as it goes along. By the time print array is done, after it's done, then all the elements in it are now equal to 0. And this is kind of like live data, you know. I mean, it's not the case where you can change this all you want, and because this is a parameter, it's not going to change it. I already mentioned that an array variable is actually a pointer. So when we're changing data like that, it's actually changing the original data. You can use the const keyword to try to avoid letting your program change things. I'm not sure if this is going to work. Let me see what that does. Yeah, see, I added the word const there. What that is doing is it's saying this parameter will never change. And then if you try to change it in your code, you'll get an error. It's not a bad idea to use const for stuff, for things like arrays. You're writing a contract with yourself saying, oh, I'm passing in an array, but you better not be changing my data on me. So, you know, you'd have to fix that. You wouldn't want to do that. You take that out. So you need to exercise caution to make sure that the array is not inadvertently changed by a function, because the array name is actually a pointer, so it would let you change the data. Two-dimensional arrays. Now, if you're editing an Excel spreadsheet, you have a grid of data, not just a single linear line of data. A one-dimensional array is just like what we've been allocating. I have 10 names. I have 4 numbers. You know, I have 7 digits, whatever. A two-dimensional array is a grid. We printed out a grid previously, and so if you're going to print a two-dimensional array, you're going to use a nested for loop, just like we did when we printed our array in that homework assignment. When you declare a two-dimensional array, you use 2 sets of square braces, like that, rather than just 1. So that looks something like this. Squares. We're going to declare a 10 by a 10 array. So we're going to declare a constant rows is equal to 10. Columns is equal to 10. And then we're going to say we want something that is that many rows and that many calls. Then we might write a loop that would go and fill in all the data. I don't know why I call it squares. This is more a multiplication table than anything else that I'm coming up with. So for int x is equal to 0, x is less than the number of rows, x plus plus. For int y is equal to 0, y is less than the number of columns, y plus plus. And the element at that position is equal to x times y. That would create kind of a multiplication table. Let's print it out just for grins. same syntax. For int x is equal to 0, x is less than rows. I think I'm going to actually make us type this in, so I shouldn't have been doing it in Notepad, implying that we're not going to type it into our code. Y is equal to 0, y is less than the number of columns. And then let's see that out. See out the array at position x, y, followed by a tab. I may change it from 10, 10 to something smaller so it'll fit nicely on a screen. Let's change that to 5, 5. And then after that row is done being printed out, we want to print an ENDL. Why? So that it'll print out, an entire row and then hit the enter key.
Does it matter which one you declare? Do you always want to declare your rows before your columns if you're doing this? Like when you did the int mult, did it really matter which one you declared
Right.
first?
If you swapped the order here, if you made it calls followed by rows, then you better swap. No, it would work. It's just that when you printed it out, you'd kind of be printing it rotated 90 degrees, if that makes sense.
Oh, gotcha.
All right, let's go ahead and add this to our Visual Studio Code. So let's write another function called test2. Make it look like that, and then put a call down in main to test2. Just make sure it works. Didn't print a dang thing out. I don't know what it's printing out. Oi, y, oi, y, oi, y. Oh, I don't know what a /y is. /t. There we go. All right, that looks better. So 1, 2, 3, 4, 2, 4, 6, 8, 3, 6, 9, 12, 4, 8, 12, 16. It did print out our little multiplication table. So you use a nested loop to access a two-dimensional array. The inner loop is traversing each row, all the columns in a row. The outer loop is traversing every row on its way down.
Did you do another for loop after that? Or one? I think I'm...
Just two inside this one, inside the test2 function, 2 for loops.
So they're pretty much the same, but what you did was you just changed where you're multiplying, you just changed it to a print function.
Right. Instead of calculating and storing a value in the array, we're just printing it back out. What kind of data would you store in a two-dimensional array? The answer is pretty much anything you want to put in a spreadsheet. So, you might have stores, You have store A, B, C, and D. And then they have monthly sales. January, February. Come on, zoom in. March, April. And so store A had a gangbusters month. They made them 100,000, but store B is not doing nearly as well. Store C was closed that month for some reason. Store D surpassed them all. Then the next month sales went down. It's only got 28 days in it. But for some reason they kicked up. These guys finally opened and started getting some business. Whatever. somebody's been cooking the books and they earn 200,000 every single month. These guys are starting to pick up. Anything that you could store in a spreadsheet would make a good two-dimensional array. Rainfall, you know. You could have different years. Again, January, February. Or let's do, you know, weeks of rainfall. Monday, Tuesday, Wednesday, Thursday. And so you'd have different weeks, you know, the week of June 1, June, you know, 8th, June 15th, and so on. And so Monday and June 1, Tuesday, whatever, you know. You get the idea. I'm not going to fill all these values in. I'm going to cut and paste. That's going to look stupid. So anything you'd use a spreadsheet for, you could use in two-dimensional arrays. Can you have three-dimensional arrays? Sure. Can you have four-dimensional, five-dimensional, six? Yeah, I'm not sure what the limit is. If you want to pre-fill, you know, initialize a two-dimensional array, the syntax looks a bit weird. Looks like this. Int 2D is equal to, and we're going to use initializer lists, but it's effectively an array of arrays. So the first row is going to have a 1, 2, and a 3 in it. The second row is going to have a 4 and a 5 and a 6 in it. And the third row is going to have a 7, 8, and a 9. And then the last row in the array is going to have 10, 11, 12. Now it becomes a real mess trying to figure out, you know, the number of rows and the number of columns. I'm absolutely sure there's a way to do it programmatically. Sure is nice in Java where you just call .size or .length, whichever it is on the array, and it tells you. So here's a case where I really would use, you know, some constants. Size of X, size of Y, whatever, you know, rows or columns. And that way, when I initialize it, I would go ahead and do that. Size of X, size of Y. And why would I do that? So that when I write my for loop that prints it out, I have, you know, some limits to my for loops.
So if you do a three-dimensional array, what exactly, like, how different would it look on the command prompt? Because like, I just looked it up just to see, but I don't see how you would make that in the or make it show.
Well, how would you print a three-dimensional array?
Well, you would just add another. Well, you'd
You'd have
have
to
X,
print it
Y,
3
and
times.
Z, and you would have.
Yeah, you'd have X, Y, and Z, but you'd have to print like multiple copies of it. You know, just like a floor plan.
Because you have,
This is my first
you're
floor.
having, it's literally, you're looking at 3 different things cross-referencing each other, so you're gonna have at least 2 or 3. I don't know.
I looked it up. I just don't know what it looked like in the command prompt. I mean, I Googled it.
Yeah. There's a three-dimensional array. So if you're going to print it out, it'd just be a series of grids. This representing the first layer, this representing the second layer, this representing the third, and so on. So when you printed it out, it'd just be, you know, a series of numbers, each one representing a layer in the three-dimensional array. Does that make sense? Okay. You don't get a real good way of visualizing three-dimensional data.
In the command prompt.
Yeah, and then if you're trying to do four-dimensional or five-dimensional, forget it, yeah. Yeah, this is great and all that, but we can't see inside it. You know, all we're seeing is the data on the last, you know, elements. Four-dimensional array. I like this one.
Jeez. I don't even know what that is.
Ooh, was a pretty one. I'm not sure how that's 4-dimensional. That looks like a 3-dimensional array to me. I guess if you have a slider, you know, that send it through the 4th dimension, then the representation of it might change. So what would you use a 3-dimensional array for? Modeling, you know, temperatures or something like that. I don't know.
It's always hard for me to think of real world examples for the stuff we do.
Well, it could literally be anywhere where you're comparing 3 different things. So you could just have like a day of the month, or you could have like days of the month, right? And then you could have rainfall and temperature for each day of the month.
Right. Or if this is a 2-dimensional array, and this was, you know, like you said,
You wouldn't be able to.
this might be sales, and then you might have another one that was exactly the same.
But
instead of being sales, I don't know what it is, payroll, you know, something like that, where each layer of your 3-dimensional array represented something
and the
else.
payroll's based off of like how much the sales are or something like that.
Yeah, or it could be by year, you know, January, February, all the way down to December, but then the next layer in the array is the next year, and the next one is the next year, and so on. So the first declarator is a number of rows by convention. The second one is a number of columns. As long as you keep your counter straight, then you could access it in either way. You know, you could put columns in your outer loop rather than rows, but then when you're printing it, you're kind of printing it sideways. If you can visualize that, it's just easier to assume that you're declaring it with rows and columns, and that your outer for loop, your top, you know, your outermost for loop, is going to be based on rows, and then the inner loop is going to be based on columns. Division 1, quarter 1 has that sales. Division 1, quarter 2 has that sales. Division 1, quarter 3. Division 1, quarter 4. How big of an array would we need to allocate for this? This is a 2-dimensional array. It may look like more, but
It's a two-dimensional array.
I guess we could treat it as a 3D array, but I would say that it's going to be a 2 by 4. No? I better scroll up and look, see what they're doing here. How did they declare their data? Sales, number of divisions, number of quarters.
3 by 4.
Yeah. If we go back, we can probably look at that. This is 3 divisions. How many quarters per division? 4 quarters per division. And that's the actual data right there. These are just place values in it, but they've changed it. You know, they did that +1 business to make it look comprehensible to humans, but really, you know, that would be
Division
0,
division
1, and 2, and that would be quarter 0 through 3, quarter 0 through 3, quarter 0 through 3, if they were printing out the index values. So 2-dimensional arrays are initialized row by row, just like I showed you, because an array is an array of arrays. A 2D array is an array of arrays. That's the top row, that's the second row. You can omit the inner. Forget that. I don't care about that. Passing in an array as an argument.
And then just a repeat of the scheme.
I'm not sure why they're specifying a size there. I'm not getting that. They're declining a global variable called calls. I would have passed that in just like I passed in the number of rows. How odd. Passing data, passing a 2-dimensional array into a function is just like passing in a 1-dimensional array. You have to pass in the array itself, you declare it with the square brackets. This business seems hinky. And then you pass in a size. The size, you ought to be passing in both the number of rows and the number of columns.
How do you change the dimensions of the array?
Just add more brackets.
Change it after it's allocated. You have to reallocate a new one and copy the data from the old one into the new one. Yeah, back in olden days, if you were a comp-sci student, you learned a lot about copying from one array into the next. And what do I mean by that? Say you had an array, Jenny looked like this, is equal to 8675309, and then you realize that we forgot the 1 in front of that. So you would create a new array that was longer than that, int new Jenny, and it's going to be 8 long instead of 7. And then you would copy all the values in, but you would fill in the specific data that you needed to. So if you wanted to put a 1 in front of it, you'd do new Jenny at position 0 is a 1, and then you'd write a loop that would copy all of these values into the new array. And then at the last thing, I'm not going to write the loop to copy all the values of Jenny into the new Jenny array. And then you'd say Jenny is equal to new Jenny. So now we have inserted a value into it. So we had to create a new array. We put our value into it. We copied the rest of the data. Deletions would work the same way. You wanted to delete that 8, you'd allocate a new array. That was 1 less, and then you'd copy all the rest of the values in by whatever sneaky little for loop you had to do. So dealing with arrays is kind of nasty if you're trying to keep its size exactly to your data. So what did everybody do? They created arrays that were too large. Doesn't matter, my computer's got a lot of memory. If I want to store a phone number in 1,000 bytes, no problem, or whatever. Why? Because it was easier to do it that way than to write functions that would insert into the middle of the array, or delete from the middle of the array or whatever. Nowadays, I'm reasonably sure that there are standard library functions for doing that kind of stuff. It manages it for you, but it'd be better to use a class that was intended to be a dynamic data type that was supposed to shrink and grow. And this chapter goes on about something called vectors, which is that idea. Yeah, arrays with 3 dimensions. Okay, we get the idea. That's a 3-dimensional array. That's a 4-dimensional array. STL stands for Standard Template Library. The C++ Standard Template Library has a whole bunch of different classes in it. Containers, forward containers, reversible containers, random access containers, hashes, uniques. Here's the one we're going to be using, the vector. That stands for double-ended queue, DQ. And then there are lists, and then there are S lists. There are also sets. The difference between a set and a list is that a set has no particular order, We're getting into, what's it called, discrete math or whatever. We don't need to talk about what a set really is, but it's different than a list because a list is ordered, whereas a set is conceptually unordered data. And so on. So, the standard template library, called template because you can create a list of strings, a list of doubles, a list of floats, a list of bools, a list of frogs if you declare a frog class, or whatever, and you can use the same syntax to access it. So that's what the word template means, is that it's designed to be used with many different data types. We're going to use one called the vector. The vector is kind of a plug-in replacement for arrays. So The standard template library vector class is a data type in the standard template library, covered more in chapter 16. It can hold values of any type. What you do is you give the data type inside the ankle braces. And we saw that with our casting. But anyways, so if you want a list of ints, you declare it like that. If you wanted a list of strings, it would be vector string names or whatever. What's cool about them is that they automatically add more space as needed. You don't need to determine the size of definition.
Oh,
You don't have to say, I need, 100 scores just because you're not sure how many you're going to have. You just create an empty vector and then you start adding scores to it and it sizes itself.
I guess so. Would it be? Well, I have two questions. My first question is, so why use a list if you like? I mean, because you never know. I mean, unless you know the list is going to stay the same the whole time. I mean, that would be a good time to use a list. But can you just change list out with vectors? Just use vectors?
I would use vectors anytime. When would be an appropriate time for an array? Well, the number of months supposedly isn't going to change. So since it's going to be hard-coded to 12 months, you may as well just stick in an array. Also, arrays are great for when you're trying to write the fastest possible code, because when you're accessing an array, there's no dereferencing involved more than just, row, comma, column. There's always a little bit of overhead when using classes and the methods, the functions that are attached to classes. So arrays are the fastest kind of data access, but for ease of use, just like in Java, I always use array lists. And there are other kinds of data forms. So, Professor Dewey may have you, use something else other than array lists. But the limit in Java is the same thing. An array is fixed in length once you've allocated it. And so if you want something that grows and shrinks, you're going to want to use a different class. You're going to want to use a class. An array is technically in class but Java. But anyways, you want to use a dynamic data type.
And my second question is, I understand that the vector, it's a class. So are your classes supposed to start, because in Java, when you use a string, just S is capitalized, when you use a string.
Right.
So, because it's a string class, it's not just the data type, it's a class that modifies the data type. But the vector, I was just wondering how come you don't.
Why it's not a capital V? It's because C++ predates the convention that all class names are capitalized.
Okay, gotcha.
Yeah. So declaring vectors, you have to use a # include. I guess we may as well
Make a new file.
make a new file, new project.
I'm gonna save this one.
So I'm going to close this solution and open a new one. Create a new source file. This is going to be a demonstration of vectors. So a vector is a sequence that supports random access to elements. Why is the term random access important? Because there are some data types that are not random access. There's another one called a stack. There's another one called a queue. A queue, you are only supposed to access it in order, like you have a line of people going into a movie theater. It'd be really unfair if you went and let the middle people in before you let the people at the beginning. Or if you have a stack of paper. You're supposed to take the papers off the top of the stack rather than reach down underneath and grab the individual ones. But a vector is random access. You can take any piece of data out, just like an array. And it's got some other features. Constant time insertion and removal of elements at the end, and linear time insertion. Okay, anyways, we don't care too much about how long it takes to insert something into the vector. The number of elements in a vector may vary dynamically. The memory management for it is automatically. It's the simplest of all the STL container classes, and in many cases the most efficient. We haven't used the assert command. Assert is a debugging tool. We'll that just real briefly since I see it on this web page. So let's add a include IOStream just in case we feel like using cout, which we probably will, and then include vector. Forgot my using namespace. Put in my system pause. Put in my return 0. Now I'm actually ready to do something. So I want a vector of strings, which means I better include the string class as well. So I'm going to come back up here and add one more include to include the string class. And this vector is going to be called names. Now they're using a method called pushback to put a number onto the array. Excuse me, onto the vector. They're calling it an array. Right there. That's why I said it. But it's not an array, it's a vector. In Java, if you were using the array list class, you would use, I believe, .add. Okay, so names.pushback. Let's add some names to it. Bob. Names.pushback Sam.
And the pushback function, I guess, only takes one parameter, so you can't just pass
Add a
in
whole bunch of them.
Okay.
I don't know, let's try it. Add Jill to the list. Yeah, it's giving us an error. Okay. Now, unlike Java, C++ supports operator overloading, which means that if you want to get the data back out of the array, you don't have to use a method. Here's what we would have to do in Java. You'd have to say, if I want to print out the first element, I'm going to do names.get, and this is not C++, so don't even bother typing it, like that. You have to use a function to get data out of it, just like you use data functions to put data in it in Java. However, C++ is a weirder language that supports operator overloading. What operator overloading means is that you could make the plus sign do absolutely anything you wanted to. You could make the square brackets do anything that you wanted to. And so they've made it so that if you use angle braces like that, you can pull data out of your array. Excuse me, your vector. So hopefully when I run it, it'll say Bob and Sam.
I put mine in a for loop, and do you want to come see what it did?
Yeah.
Okay.
The function that determines the number of items in the array is .size. So you're not going to use size of. That would return the number of bytes that the array is allocating, that the vector is allocating. So let's add a few more items to it. Names.push underscore back. Got a few girls, Sue and Peggy. It's funny how names fall out of fashion. Okay. Now hopefully, since we've added 4 names to it, there are 4 names on it. If we wanted to write some kind of a automated process that was testing this code to see if it was working or not, you can use something called the assert keyword. What assert does is you do something like this. Assert that names.size is equal to 4. I apparently used the wrong syntax. what, do you have to pound sign include assert? Then forget it, I'm not gonna demonstrate it. Okay, but if we printed out the size of it, it would be 4. So let's print out these items. For int I is equal to 0, I is less than names.size, I++. And then let's see out names at element I, followed by ENDL. And I'm going to comment out these two outs because we're going to be printing the whole list, you know, just in a minute.
So size is a function for lists or arrays, or is it?
It's an STL function.
Okay,
So no, you can't call .size on an array in C++.
just on
In
vectors.
Java, there is a .length function, .length method, because in Java, everything is a class. Arrays are classes. So there is a method for returning the length of the array.
So it just works on vectors?
Pardon me?
The dot size only works on vectors?
No, size will work probably on any STL library class.
Okay.
It's just .length in one language, .size in another, but then there are classes in Java that also use .size, so you just type .size, and then if it gives you an error, you change it to .length and go, oh yeah, I was programming in Java, or whatever. Yeah. One of those little things where you have crosstalk in your brain. So I'm going to run it, and it says Bob, Sam, Sue, and Peggy. So it grew automatically. We didn't specify a size here. We didn't have to say, oh, I want space for 4 names. That's great if you do not know how many items are going to be in the list. For example, if you're reading in a list of file names from a directory may have no files in it. Heaven forbid, a directory may have 100,000 files in it. Your file system is going to kind of start creaking and groaning if you've got that many files in a single directory. Can you imagine doing a save as and waiting for Windows to load 100,000 file names, you know, to populate the save as dialog? Anyways. So that's what's cool about a vector, is that they're dynamic. They reallocate themselves. A vector is a dynamic data structure that resizes as elements are added and removed, unlike an array. The reason you use these dynamic data structures, besides the fact that they grow and they shrink, is what if we wanted to delete the 5 from the middle of the array, 8675309. You know what you'd have to do? You'd have to copy the 3 into the 5, the 0 into the 9, the 9 into the 0, and then you'd have to wipe that one out with a 0, or whatever, you know, or decide how you're going to handle the last piece of data. Insertions and deletions in an array are really messy business, really, really messy business. That's why I said, you know, in comp sci, you'd spend, you know, 2 weeks learning how to write functions that would manipulate an array to handle assertions and deletions. You don't need to do that anymore because you have vectors and array lists and things like that. So unlike an array, insertions and deletions are easy as pie. Unlike an array, it is not fixed in length. Once you allocate an array, it is of that length until you allocate a new array. Vector is a class in the so-called STL library, which stands for Standard Template Library. What does template mean? Template means that you can use the class with any data type. Int, float, long, double, your own custom classes. So you declare it like this: vector int, IB, vector double, that kind of stuff. Vector string, names. Here's one difference between Java, and I know you guys who aren't taking Java are annoyed, but I know this, you know, 3 of y'all are. So in this language, you can mingle primitive data types and classes like that. But if you're going to use a dynamic data type like an array list or a stack in Java, you can't use ints and doubles. You can't use the primitive data types. You have to use the capitalized version of it, which are the wrapper classes.
And there's wrapper classes for every data.
For every data type in Java, right, exactly. Okay, so I think that's about enough of that. Let's go back to the PowerPoint. You use the size member function to determine the number of elements in the vector. I wouldn't say the size of the vector because we've been using size of. Size in the past has meant the number of bytes, you know. So use the size member function to determine the length of the vector is what I would say. Use push underscore back to append an item onto the vector. Use dot size to determine the number of items in the vector.
There's like no push and pop, I guess I could say.
Well, push is push.
There's push, but there's
And then
no
pop, there is a pop as a matter of fact.
Okay.
If you feel like pretending it's a stack. Well, I mean, not pretending, you're actually using it as a stack. Pop removes the last element. That's worth demonstrating actually, although I don't use stacks too often. I always teach them in Java. I don't teach them in C++. But now we have 4 names in our vector. Let's pop some things off. We're going to write a while loop that's going to remove all the data. So while names.size is greater than 0, let's get the name out of the array, names.pop back, and let's print that name out, cout s-e-n-d-l. And it's complaining I've done something wrong. I
No
guess,
suitable constructor exists to convert from void to
okay, let's try casting it.
lots of crap.
Fine. I'm not going to spend any more time on that. The idea behind a stack is that you have 2 commands. Push tacks things onto the end of the stack. I'm going to rotate it in your head now. Push puts things on top of the stack, and pop takes things off the stack. So it's called LIFO, last in, first out. Some people say FILO, first in, last out. Why do you say that? No, that's not right. It's FIFO, first in, first out. I need to draw a picture. You have a stack. You stick Joe name on it. Now there's 1 item on it. You stick Bob on it. Now there's 2 things on your stack. And then you do a pop, okay? You've removed Bob from it. That was the last item that you added onto it. So it's the first item that you accessed. So stacks are LIFO, last in, first out. Then there's other things called queues. Queue is like a line. And like I said earlier, if you had a line of people and you started letting people at the end of the line into the theater, then the people at the beginning of the line would be annoying. So in a queue, as you add things to it, you're adding on one end, but you're removing them from the other. You know? So Joe stands in line, and then Bob stands in line, and then Jack stands in line. You have 3 elements there, and then you take that guy off the queue. He was the first in line, so he gets to be the first one to go into theater. So queues are FIFO, first in, first out, where stacks are LIFO. These are much easier for people to conceptually understand. It's not that these are hard to understand. Stacks aren't hard to understand, but coming up with reasons why you use them is somewhat difficult. I mean, it's not difficult, but for example, a printer queue. You would not implement a printer queue as a stack. Why? Because that would mean that the last person to send their job would be the first job that was handled by the printer. And so if you were getting ready to print your document and then somebody slipped in and then printed out their 10,000-page novel, you'd be sitting there waiting for their document to get done even though you submitted yours first. So stack would not be an ideal data structure for a printer queue. Instead, you would use a Q, kind of implied in the word printer Q. When you do, you use stacks, essentially when you're doing programming. An example of that is undo. I'm going to type a couple of things in, like this. Hello. And then I'm going to type Bob, and then I'm going to type Joe, and then I'm going to hit Control Z for undo. It took Joe out. Last in, first out. Then it took Bob out. Then it took hello out. So the undo list in a word processor or whatever, anything that supports undo, is actually a stack. Another example of where stacks are used is in programming languages themselves. If you have a function that looks like this, foo has got a variable called x in it, and then bar has got a function, has got a variable called y, and then bar calls foo, and then down here inside main, you call insert blank page. Okay. All right. So then down in here in main, you call bar. It allocates and frees up memory on a stack. What do I mean by that? Whatever. I know you're not supposed to write on these things, but whatever they're good for, if not. Nope, this one is definitely writable. Or maybe not. I've never seen these things work, these kind of Bluetooth activated screens or whatever they're supposed to be, since I started working here 10 years ago. So I don't even know why they're still pasted onto the side like that. Okay, so we're inside main. We call bar. So over here on the stack, bar gets a new variable. It creates an integer. And then it calls foo. So we push another thing onto the stack. Foo has got an x variable. I don't know why I put y int and then like that. It hits the return. We bail out a foo, that gets taken off the stack. We bail out a bar, because we hit that return, that gets taken off the stack. Now there's no extra data. So variables, local variables, are allocated on the stack. And as you keep going into functions, the stack increases. And as you pop out of the functions, the stack shrinks. So use stacks when you're writing your programming languages. It's more of a programmer's tool, a concept, than something that an end user thinks about. You'll never have an end user come up and say, well, I want you to implement something as a stack. They're always to say, I want a list of names, or I want a list of whatever. And for us, a list and a vector are interchangeable terms. Removing vector elements.
What we were gonna do.
Use popback to take the last element from the list. You want to wipe them all out, you use .clear.
Oh, well.
To check to see if it's empty, you could either use .size is equal to 0, or you could use .empty. So here we go. We declare a vector of ints, and they initialized it like that. Notice there was no equal sign. Again, C++ allows strange syntaxes that would not work in other languages such as Java or Python. Display the vector items for every value in the numbers. Notice what they're doing here. Do you remember when we said that there were two different possible syntaxes for for loops?
Yeah.
One of them used a counter, and then the other was a for each loop. Maybe they didn't call it for each loop, maybe they call it range based or something like that. But this is saying for each value in the vector printed out. So we could have written our loop like that in our code. Go back to here. I'm going to delete that because that did not work. But for our for loop, let's write another one. For every int, I'm going to say E for element, not I, because I is my index counter. That's just my personal quirk. For every element in the names, oh wait, these are strings. Okay. For every string in the names list, see out that string. This syntax worked with arrays. It also works with vectors. That'll iterate through the list. Again, I like that syntax better. And it works in Java as well as in C++. It's well worth memorizing. So it just printed out the list twice. Bob, Sam, Sue, Peggy, Bob, Sam, Sue, Peggy. Alrighty, this seems to be acting like a stack. Can you insert into the middle of a vector? Good question. I'm so glad I asked it. I don't know yet. But there are functions. Capacity returns the maximum number of elements that the vector can store before it allocates itself more memory. What does that mean? When a vector is created, it gives itself a little bit of space. And then when you exceed that, it allocates more. And then when you exceed that, it allocates more. It doesn't do it every single time, because that would take time. You know, it's better to give yourself like room for 5, and then if you fill up those 5, go and grab another 5, and then grab another 5. It might be fun to play with capacity to find out how many items our empty vector was capable of holding before we had to add anything to it. So I'm just going to add a print statement up to here. I'm curious what the capacity is of our vector. The capacity means the number of items that could be added to it before it decides to give itself more memory. Names.capacity. Is this important? Not really, because it's all handled behind the scenes. This is just kind of out of curiosity, and they did show it there. Okay, so it's saying that the empty vector has room for 0 before it has to allocate more memory. How about once we add those 4 items? What is its capacity? I'm going to move that line down here. 4. All right, it seems to have the exact same capacity as the number of items. How about if we use pop to remove something from it? I'm going to take the last name out. Names.pop back. Now whenever I print it, it's no longer going to say Bob, Sam, Sue, Peggy. It's just going to say Bob, Sam, Sue. It's still got room for 4, even though it currently only has 3 items in it. Why? It's not bothering to go and modify the memory just because we removed 1 item. I don't know at which point it would go and free it, or if there is a method.
So does it technically even shrink then? I mean,
That's what I'm wondering. When does it shrink? Is there a method for triggering a shrink? I'm going to highlight vector and click F1 to find Microsoft's definition of a vector, not Silicon Graphics. Member functions. You can assign into the middle of the array. You can get the last element back.
What's a random,
Clear erases them all.
what's the random access element again? Or
An iterator
iterators?
is a tool for stepping through it with a kind of loop. We'd have to put on our pointy propeller beanies to talk about iterators. So I'm going to beg that question off. If you really want to know about it, I'll ask you to go read it, and then I'll explain further.
Okay.
So erase removes a single element or a range of elements. That's what I was looking for, a random access way of deleting stuff from the middle of it. Resize. Shrink to fit. There we go. That's the function that you would call if you wanted the vector to free up the memory that it was no longer using. It's kind of silly to have to do that manually. Java follows the idea of garbage collection, which is if you don't need the memory anymore, eventually something comes along and removes it so that you don't have to manage it explicitly. C++, not so much. So if you are adding and deleting from a vector a whole lot, you might want to call shrink to fit occasionally. I probably wouldn't bother unless I found out that there was a good reason to do otherwise. Reserve. You can set the minimum size of the vector. You can say that no matter what, I always want it to have 10 spaces. Why would you do that? Because when your program is running, if the vector decides it has to allocate more memory, that's time that it has to sit there and stop in order to juggle memory before it can pick back up. And kind of like I said, an array is the fastest possible. The reason it's fast is because it's not doing anything like that when it's accessing elements of the array. It just knows right where things are. So if speed was of the utmost, then you might want to reserve a certain amount of space in your vector so that, it could have space for up to 100 elements to be pushed onto it before it had to reallocate anything. That way, when it was adding those 100 items to it, it would be adding to them as fast as possible without having to allocate extra memory.
So I guess all the like the classes that people make, they make everything, I guess, more easy to use, but everything's slower, I guess, than, like you said, like using a list would be fast, or an array would be faster.
Right, there's always a trade-off. You're writing a class to try to make using that form of data easier, but it's slower slightly. But nowadays when things run at, multiple billions of instructions per second, speed is not quite of the essence that it used to be. On the other hand, if you're writing a video game, speed is still awfully important. And so you're making a judgment call. If you use a STL, like a vector or an array list or something, then the syntax for it is very clear, and you don't have to worry that you're writing past the end of the array, or it removes a lot of the complexity. And so the code is easier to write. The code is easier to maintain. So if you're writing for maximum speed, you're going to be making your code more difficult to read, and more difficult to write, and more error prone. You just have to kind of decide what's most important. Most of the time, you want the code to be as easy to read as possible, and you want to trust that the thing will run fast enough nowadays. But if speed is of the absolute essence, then yeah, arrays are really how you have to go. Question?
Let's go back down to the string S-name part right now.
Like that?
Yeah.
Okay, cool. I'm going to delete that capacity line because I don't really care about the capacity. I'm going to remove this pop back because I don't care about how to remove an item from the end of the array. But we are going to talk about insert. You don't always want to add things to the end of the array. You might want to insert something into the beginning of the array, in which case you use .insert. Let's say that we got some guy named Abe, and we want to stick Abe at the beginning of the list. Got to decide where to do that. Names.insert. I always forget whether, okay, we put the value first and then the position. Let's find out. Abe is going to be our new element 0. Is that the correct syntax? Let's find out. It's complaining about it. I might need to reverse it. Okay. So 0, Abe. And don't tell me that's wrong. Okay, fine. Make me look it up. Vector, string, insert. Inserting strings into a vector. Insert should be given an iterator to insert into a certain location. Okay, I've gotten spoiled by Java. I'm not going to talk about insertions if you have to use nasty things like iterators. Okay. Forget that. Sorry. I'm not going to talk about insert. Let's see what the PowerPoints are talking about. Resize, who cares? Reverse in the order of the elements in a vector. That might be fun. Let's reverse our vector before we print it out the second time. Names.reverse. Now, okay. I swear I saw reverse pop up as I was typing. Reserve. There's no reverse. Slides are on. Okay, reverse doesn't work. Who cares? And then there's a swap. If you have two name lists and you want to swap them, you could use .swap. All right, that's the end of the chapter, actually. I'd rather see a little bit more information on vectors. So, vector, C++ examples.
Was the last time they updated C++?
There's a newer version. 2015, 2017, I forget what the standard has been dated. Here they are creating a vector that contains the contents of an array, and it's automatically calculated. I mean, it's automatically inserted as they did. You asked if you could add more than one item to it at the same time. Well, this creates the array and it initializes it with the values. Creates a vector and initializes it with the values of an array. And it follows some nasty syntax for doing that. I'm really not happy with, or I'll just say that I love Java's simplicity of their collections classes over the STL library.
I guess, in all honesty, I haven't seen why C++ is mainly used for art, like why it's the top gaming language. I don't see it. 'Cause it just seems nasty to me.
It compiles into an executable rather than being run by a runtime interpreter, and any program that is interpreted takes a lot longer to run. So Python is a slow language, Java is a slow language, JavaScript is a slow language. All of those are interpreted. Now, some people write compilers that will take a language like Java and try to create an executable out of it. But really, you want to, if you're trying to write something that's high performance, you're going to write it as a .executable, which means that you're going to use something that generates an executable, which is probably going to be C++. All right, I'm not seeing any reason to talk further about vectors. We hit the end of the chapter. We've talked about pointers. I don't see any reason to give you all an assignment over vectors. Do read the chapter about it. There'll be a couple of questions, but the questions will just be things like, which data type resizes, the vector or the array? And the answer would be vector. How do you add an item? You use push back to add an item. How do you print a vector? I guess I really should create an assignment if I'm going to ask all these questions about it, but let's put the two syntax. I will paste these notes into the notes and then put a comment here. What to know about vectors. That you must use # include vector. That you create a vector with the angle brace syntax, like I want a vector of ints, like that, or a vector of strings. You add items with .ints, .pushback. You access them with like that, just like an array. You can also use .at. So nums dot pushback would add 100 onto it. So if you coutted nums at element 0, it would print 100. That's really enough. Okay, and dot size. To calculate size, to get the number of items, use the dot size method. There may be classes that make using this stuff glossier and easier, make more sense than the STL library, because again, the STL library dates back to the 90s too, and then people's thinking about how to write this stuff has continued to improve since then, which is why you see subsequent languages have clearer syntax, Python being a great example of that. Okay, homework. We already have a homework based on arrays, do we not? Didn't I say take the rainfall assignment? And so this one's going to be really easy. Homework. Create a 10 by 10 array. It's going to be a two-dimensional array of ints. Fill it with random numbers between 1 and 9. And then print it out as a grid. All right, that's all I'm going to say about it. If you need more hints about it, then ask me, and I can give you additional hints. If you were going to create a sum of a two-dimensional array, it's very similar to creating a sum of a one-dimensional array, except you have to use that nested syntax. Remember how we did the sum of a one-dimensional array? We did that, and then we did something like for every I in the array, sum plus equals I. Well, that's the cleanest syntax because we're using a for each. But if we had to do it old school, we would do it like this. Oh gosh, oh well. X is equal to 0, X is less than the size of the array, X plus plus, hopefully size of array is something that you have saved as a constant. And then the sum is plus equal to the array at that specific element. A two-dimensional array just has a nested loop in order to do that. So, sum of a 2D array for int r for rows is equal to 0, r is less than the number of rows, r plus plus. For int c is equal to 0, c is less than the number of calls, c plus plus. You better have determined the number of rows in the columns before you start doing this. And then sum plus equals the array at row column. Okay, so we may as well tag that onto the assignment. Print it out as a grid. Display the sum of all the elements of the grid, of the array. All right, that's as far as I was planning on taking it today, so why don't we go ahead and stop. If we have questions over homework, quite happy to hang out and talk about it afterwards. We're supposed to, keep going going until 10 actually. So, or if you wanted to sit down and do the homework right now, you're also absolutely free to do that.